sort of welcome. Great. Thank you for starting the recording there. So there is a Google Doc as part of the room. You should see that if you're logged into Kiko Chat. So what we've got some notes in there with a link to the slides, link to the scienceonschema.org guideline documents for the data set and the repository, and then sections for us to keep notes on some issues that we're really trying to resolve as we drive towards this Esip assembly endorsement. We'll describe what that is and where we are in that process in a second. And then for each of those issues, there's a link into GitHub, which will give you sort of like a context of where we are in that issue in case you want to read ahead or jump right in and add your own comments to those issues as well. And so we've tried to give you some links in here to really engage in the process of where we are. And so I think we can get started here. Please feel free to put your name and affiliation there, plus any other information you'd like to put in about yourself in the Google Doc. Up at the top, you'll see attendance and check-in section. And it'd be great to have a record of who showed up here. So, all right, let's get started. Okay, so first just wanted to kind of give you a sense of where we're going so that if you feel like this session isn't for you, you can quickly exit and we won't see you get out of your seat or hear the door slam. So please feel free to jump in. We won't be offended. We want this to be meaningful to all the attendees here. Okay, so we will give a brief introduction into the scienceonschema.org initiative and what the schema.org cluster at Esip is doing. And then we have a couple of short 5-minute talks to describe, okay, what is the benefit to publishing schema.org on your website? And it'd be great to see some of that. And then we're just going to sort of show you where we are in that process of moving these guidelines that we've drafted for using schema.org in the sciences or the geosciences to an Esip assembly endorsement. And so we'll show you where we are in that process and what the roadmap looks like there. And then we'll give you an update on sort of what we've been working on since the last time we've met and the last time that we published out a new version. And then we've got some selected issues that we're still trying to work through before we can go ahead and apply for that Esip endorsement. And that's because we really want the version of the guidelines that Esip endorses to be long-lived and stable for a good while, so that there's not these minor revisions to certain things that would trigger us to get an updated endorsement. So we really want to have a good version of these guidelines prepared for Esip. Okay, so what is the schema.org cluster? We're really focused on sort of honing in on some common publishing patterns to describe research data on the web. And so we sort of sit in between this space where the larger web publishing community is using this vocabulary schema.org embedded in their web pages through multiple ways. It could be inline in the HTML or by scripts that pull in this information, but it's about describing the contents of that particular web page. And our focus sort of sits in between what's going on in the web publishing world and what the work that we're already doing with, say, DOI metadata and other metadata standards. And how do we bridge the gap between those two so that we can also announce to the web and its harvesters what our research data products actually are. And so to do that, certainly the big goal is really that we all share these same publishing patterns, right? It's one thing for us all to publish schema.org, but if we're not using some consistency and shared ideas and conceptualizations around how to use it, then it becomes a little bit more difficult to use. But if we do share them, then we really gain the value of having reliable, consistent federation, and then also sort of automated validation tools that will tell us how well we're doing in being consistent with the guidelines that have been set forth. So our cluster has a couple initiatives. The first is that we monitor the monthly schema.org updates. And so that initiative, primarily run out of Google, is a number of folks in the web publishing community coming together, refining this vocabulary for describing things on the web. And each month they publish out updates to that vocabulary. And so our group monitors those updates, and then anything that's relevant to the work in the geosciences for describing research data or the repositories, we'll incorporate that and consider it for our guidelines and how we should describe it. Secondly, we operate all on GitHub, largely outside of our monthly telecons, or bi-monthly telecons, I should say. We accept contributions and issues there. So a lot of our work is really asynchronous in the GitHub issue queue and managing work that way. And then, thirdly, we sort of maintain and publish these guidelines on GitHub and publish that using their sort of pages feature that sort of renders that content as almost like a website. And so largely, like I said, we're focused on describing data repositories and then the data sets themselves. And there's a Slack channel on the Esip Slack that you can get involved in. We also have a mailing list. And if you've grabbed the slides here, you have a link to our sort of living agenda. So every time we have a monthly Esip meeting or bi-monthly Esip meeting, the first Monday of the month and the fourth Thursday, we keep notes in the same Google Doc, and it's just a running history of what we're doing. Okay, so just sort of giving you an overview of what's in these guidelines. We have descriptions of how to describe a data repository. And so if you're operating a repository on the web, this schema.org might be embedded on your homepage, and that would describe things like your repository itself, maybe your funding, the organization at which you sit at, and any offerings or services that repository might have. And then secondly, and probably more importantly, is we've got guidelines on describing data sets themselves. So things like their identifiers, what variables are contained within them, what metadata records are used to describe those, your sort of common temporal and spatial coverages, the folks that were either authors or contributors, who might have published it, who have funded that data set, the licenses and things like that. So, schema.org, has a website, it has guidance on how to use it. What is the point of publishing out these guidelines? Well, outside of just sort of having some common shared pattern, when you look at the schema.org website, it's really hard to decipher these sort of like flattened pages and clicking through it. And so one of the things that we wanted to do was offer up drawings, but also examples in the sciences that would make sense to our community so that we could further just sort of broaden the context of understanding around how to use the vocabulary. And so as you see here, I'm just throwing some examples of drawings that you might find, and then some code examples on how it might be used. And so one of the things that we're doing, there's a bunch of ways that you can publish schema.org. So certainly RDFA or JSON LD. And so we've chosen JSON LD as our sort of preferred way to publish schema.org, and just gives us a consistent way to provide examples to the community. All right, and just wanted to highlight and take an opportunity. This is something that we highlighted at the winter meeting, but Karen Payne and Chantel Very, two folks that have been a part of our community, have written this really great primer on schema.org, and a lot of the high level how and whys this is important and useful. And as part of the Esip assembly endorsement document, we're going to provide a link to this primer. I think Chantel might be on the call here with us, and she's just getting a DOI for this work. She's put a lot of time and effort into it, and a lot of community feedback has gone into this. So I think we can get you a copy, but I just wanted to run that by Chantel first so we can have her chime in later. And then lastly, what I want to say about the Esip schema.org cluster is that, this work sort of spurned off some small NSF funding. This project sort of moved into the Esip space where we could gather a little bit more community coordination and governance. And so if you go to the GitHub repository for Science on Schema.org, you'll find documents that walk you through how to make contributions and how we work as a group together. And so we're always interested in folks chiming in and contributing issues. By no means is this sort of like a locked community. We're really open to contributions on all sort of topics and current issues. So we invite you to engage us there, but also in the bi-monthly telecons there which will have information at the end of today. Okay, so how's that being used? I want to give a couple examples. The first one is probably the most obvious driver here is the Google dataset search. And I think they've done a really nice job of taking the content that they've seen published about datasets using schema.org and have built this website, datasetsearch.research.google.com, where you can type in whatever your keywords you're looking for and then find nice lists of data sets that match those. And so we've got a couple other links on this slide. So Google dataset search by the numbers, you can get a sense of what those are looking like. And then also, I think this is a research paper here on building a search engine for data sets on the open web ecosystem. So feel free to check out those resources. But more specifically in the geosciences, wanted to highlight two other examples of how this work is being used if you choose to adopt schema.org in your website. And so first up, we'll have Matt Jones from Data One describe what they're doing with schema.org. And then just after that, Doug Fills to talk about NSF EarthCube's geocodes project. All right, so Matt, just let me know when you want me to advance the slides. Happy to do that.
Thanks, Adam. Yeah, so if you noticed in the last slide on the Google dataset search, there's a nice rendering of the spatial coverage of the data set. This data set comes from the Arctic Data Center, but it's also present in the Data One catalog, and presumably Google would pick it up in other catalogs if it were also represented there. And so Google's, some of the issues that we're starting to deal with are how to make sure that when data sets are represented in multiple places, that they show up properly across Google. And when we're harvesting for Data One, that's a similar issue. So go on to the next slide. For Data One, we've built a schema.org harvester that complements the existing protocol harvesters that we have in place. Data One's a network of data repositories, currently 46, that we harvest all of the metadata from those different domain-specific groups. We index and provide search engines for a lot of different fields, for hundreds of different metadata fields, including some of the core ones here: citation, space-time, author list, variables, provenance. Traditionally, what we've done is harvest and index the domain-specific, really detailed metadata records like EML and the ISO 19115 family of standards and FGDC and DDI and other things like that. And we've harmonized them all into a single model. And what we've done now is to add data schema.org to that list of things that we can harvest. And so now repositories can more easily join Data One by simply giving us a link to their sitemap and follow the science on schema.org guidelines. Dave Vigleas, Peter Slaughter, and Jing Tao have really been working hard on getting this implemented and working through all the challenges that we find in all the heterogeneity and the records that we find when we start harvesting across different groups. They used the Quasi HydroShare and the Bicodemo repositories as two really great examples of really nicely filled out schema.org. And so we've now added two member repositories to the Data One network this weekend. It added thousands of additional data sets. So you can see here, I did a quick search, data coverage in 2021, and you can see content from the KNB, from HydroShare, from the Arctic Data Center, from Bicodemo, from EDI, LTR, and many of the other repositories that are there. We have a spatial search feature and temporal search, which is really, I think, Data One's already a pretty advanced search interface across these metadata standards, so we're able to leverage a lot of that for the schema.org work. You can go to the next slide. So one of the things that we can do in Data One that I think is really, useful is that we go beyond just what we get from schema.org, and we can leverage a lot of the other services in Data One for schema.org content. So we can build custom data portals within Data One where you can select a subset of content. Here's an example where we built a portal for the EarthCube affiliated repositories that are members of Data One. And you can see that there's there's 15 repositories that we have that are part of the Council data facilities that have about 163,000 data sets in them. And we can do things like build metadata quality assessment chart. So we have an automated fair assessment that runs against all the data sets. And so by being harvested through schema.org, you automatically get per data set reports on metadata coverage. as well as getting overall collection level reports on and others as part of the Metadata project. And then we also have built a citation tracker. And so the citation tracker allows us to harvest all of the citations to the data sets that we have registered in Data One. And so for anybody that has put in a schema.org data set or a data set through another means, we're collecting information from the DataCite event data service and other sources, and registering and building a citation tracker that lets you find out who's been using your data, who's been citing it, and who's been reporting on that. And you can see that over time as well. The next slide, Adam. Two of the more advanced areas that we have capabilities are in variable semantics and provenance. When people use schema.org to describe their variables in detail, we're trying to get them to use controlled vocabularies to basically very explicitly say what kinds of parameters are measured. And Data One provides facilities for looking up the linked ontologies and displaying in a nice human readable way what those terms mean, and then provide links to find other data sets that measure that same type of variable. So you can do automatic searches that are driven that way. Similarly with provenance, if you follow the schema.org guidelines on provenance, you get a nice display of, for a given data set, which data sets were used as sources to that, what scripts and programs and processes produced it, and what was derived from it. And so that provenance information is all built into the display, and that's part of the schema.org guidelines as well. And so the final slide. So I wanted to sort of highlight a few things of issues that we've had kind of going through actually building the harvester around this. We're trying to harvest content efficiently. It's quite burdensome when you start harvesting dozens and dozens of repositories. And one of the biggest challenges in figuring out when content has changed and when you need to grab a new copy. And so we use an algorithm for deciding when stuff is last modified. It's really helpful if people put in their sitemap files that when content changes, or in their HTTP headers, or in the content itself. Ultimately, we fall back to a checksumming and versioning approach where we retrieve the JSON LD, normalize it, checksum it, and see if it has changed from the last time that we harvested it. And if we haven't, then we don't update it. But using this approach, we're able to, because we don't have to harvest every single record from every single site, we can harvest really frequently. Some of our harvests are on minute-by-minute basis, and so you can get updates really quickly across sites. Another challenge was in context processing. There are 4 different ways of representing namespaces. 3 of them all resolve to the HTTP namespace for schema.org, and the last one resolves to an HTTPS namespace, and we had to kind of think through how to do that. So we've sort of modified our processing to use JSON LD compaction and expansion to basically map back to the HTTP namespace. So this is an issue I think we need to raise back in the cluster about namespaces. We've also had challenges with dealing with lists and creators and authors and descriptions and abstracts, and making sure that we're getting the right content displayed. Of course, finding errors in the JSON LD that prevent processing. So it's really helpful if people validate their JSON LD content to make sure that it's going to work with the processor. And then finally, I wanted to mention that we're going to be populating, we're building a Data One graph store in addition to our search API that's accessible. And that graph store will allow us to further expand the sort of semantic vocabularies that we support for search and retrieval across Data One. So that's it for the Data One side.
Great, thanks, Matt. Let's see, next up, we've got Doug. And there we go.
All right, great, thanks. So I just wanted to talk a little bit about some of the work that the EarthCube office has been doing with geocodes. And I think, building off like what Adam mentioned earlier, right, that we're talking about having consistency and kind of a shared patterns and context. This is incredibly valuable when you're building tools, right? One of the really nice things about what you're seeing here is that the fundamental principles that the science on schema and the structured data on the web approach is built on is the web architecture, right? And what that has allowed is providers to expose material that can be utilized by Google Dataset Search, that can be utilized by Data One, and can also be utilized by the EarthCube Office geocode site. And so similarly, we're looking at those shared patterns and able to use those to extract information that we need to build faceted searches and elements like that on the index that we generate. You can go ahead and go on to the next slide, Adam. So, one of the things that we're doing then is really kind of trying to explore what can we do with the information that people are providing utilizing these patterns. So one of the things we're looking at are things like sample identifiers. And so there's some guidance inside Science on Schema for those types of sample identifiers. Some people like Steve Richards and others have been looking at how do we interconnect, for example, the EarthCube dataset graph that we generate using these principles with things like the resource registry graph, and allowing us then to see if we can express or expose in that process connections between data sets and in this case, tools, whether they be software libraries or online tools or things like that. And again, I think that kind of goes back to this kind of useful role that Science on Schema plays here as that discussion area to align these types of approaches in this shared context that we're moving forward with. So again, I think it's really been useful to have Science on Schema there as that area we can go to discuss these types of approaches, discuss how these things can be expressed by the facilities in ways that are still in line with how other facilities might index those resources as well. So Adam, you can skip to the last slide here. And so I guess I just want to kind of say that to us, one of the nice things is that there's these kind of broad cross-cutting concepts that I think are really important that we can all share. And then you're also going to see, I think, a large number of community indexes start to come out of this. Again, I think one of the most exciting parts of this to me is this kind of web architectural foundation. And what it means is that really anyone can come along and start accessing and utilizing this information over the net. It may be just for simple analysis on one or two repositories that they're interested in. It may be something like what Data One or Google or even Geocodes is doing, trying to actually build an index of use to a broad community. And I think that web architectural foundation is fundamental in this. And in fact, we're actually utilizing the structures within Science on Schema and these principles to then collaborate with some other EarthCube groups like Throughput, and seeing how we can then integrate information coming from the Throughput environment into the Geocodes environment and display that information. And I think then this kind of federated exchange between organizations facilitated by these Science on Schema principles is very important in that regards. And there's some other work coming along that I'm involved with called the Ocean Info Hub with the UN that again is using these same approaches. And I think that ability to leverage these principles to develop these capacities and as a way to do the kind of value add things that you've seen both from Google Dataset Search and Data One, as well as I hope Geocodes, is really encouraging for what the future holds with Science on Schema. And that'll be it.
Thanks, Doug and Matt. That was great. All right, so we wanted to get through, some of the sort of one-way communication of this session out of the way early and not take up too much time so that we could have the majority of the session really be open to discussion. And that's largely driven by this roadmap to Esip endorsement. So, we had decided that the next version, 1.3, would be the version that we put forth to Esip to endorse. And we had a very ambitious schedule set out from the winter meeting, a lot of sticky topics and issues. And I think we've done a really good job of getting through some of that. But we still have some issues that we need to address. And we felt like we'd take this opportunity to bring some of those issues forward to the larger community to weigh in and talk through some of those. And so, as we drive towards the endorsement, we were expecting to have version 1.3 done about this time, but we feel like we need a couple more months to get that together and published. And so we're really targeting September to publish that and then submit the draft of the endorsement to Esip, and you can see some of that work going on in that Google Doc link if you're in the slides. So feel free to check that out. And then there's a 30-day comment period on the endorsement, or the endorsement package rather. And so we're really hoping to have everything wrapped up by early winter, late fall here. And so in winter of 2022, at that meeting, we can all throw a party for hopefully a successful endorsement. And so just to give you a sense of where we are in this 1.3 version, we've had a lot of really great discussions here and have completed 3 topics in there. And so the first was, how to express the checksum for individual data files or files within sort of a data set package. Also, we've sort of figured out or improved the way to describe the funding awards and the grants that might have sponsored the data set work. And then also a really sticky issue there of preserving list order, which isn't necessarily something that is out of the box when you're looking at the JSON LD for schema.org. And so the group worked on that, and we had some really nice work done there. And that's really important when you're talking about, the author list or the order of variables that might show up in a particular file or data set. All right, and so here's where we are with the remaining work. And so, if were engaged with us on the winter meeting, we had a lot of discussion around variables, and we feel like the architecture there is largely complete. And you can see that at issue 27. And Steve has put together, Steve Richard has, done a lot of the work here, and he's been a real iron horse in getting that over the goal line for us. So Steve, I want to just give you an opportunity here to just sort of chime in and give the community an update there if you'd like.
Well, there's a pull request in that's been reviewed and revised over several. So if you go to issue 27, I think you'll see a list to the pull request, which has the revised text that would be update the data set guidelines. And I invite everybody to have a look at that. And we're still looking for comments and feedback on that. The basic issue is that schema.org out of the box has a fairly good way to deal with describing variables that have simple numeric values with units. But the issue is that with science data, we have lots of other kinds of data types that are used to populate the attributes in data sets, ranging from controlled vocabularies, but also things like grids and arrays, data objects, images, recordings. How do those things get plugged into describing the content of a data set? So that's what we're trying to address with this issue. So if you're interested in those things, take a look at issue 27 and the pull request on that.
Great, thanks, Steve. And so we have 10 issues in total that we want to work through, but 6 really that we wanted to bring forward and talk about in today's group. And so the first one of those is how to describe citations for related resources. This is something that you see in like your data site metadata, describing maybe methods, papers, results, papers, things like that, or other data sets for that matter. So we want to talk through a little bit about that. The second topic is how to cite sort of the authoritative version of a data set. And this is really about, metadata aggregation. And so if one site is aggregating data sets from another site, how do you specify to Google and the other harvesters that, hey, even though this data set shows up on my website, I really got it from this authoritative source for that. The third issue is specifying a preferred identifier. And so this is in cases where you might have multiple identifiers for a particular data set. Is it valuable for us to specify how to present what is the preferred identifier? Fourthly, how to specify keywords from a vocabulary. So if you're using a vocabulary like GCMD or whatever it is, a specific keywords list that has like defined terms in a place on the web where you could go and look those terms up. Is there a way to specify not just the word or the string value of what that keyword is, but can you define like the URL where folks could find more information about that particular keyword? Fifth is some really great work doing or sort of incorporating deep time into the temporal coverage. And so schema.org right now only supports ISO 8601 date formats for describing temporal coverage. And so we're wrestling with how to incorporate deep time into that sort of temporal coverage. And we'd like to talk a little bit about that today. And then also how to describe composite data sets. So if a data set is sort of a part of another, how do you sort of describe that composite? And then there's a couple other issues that, probably, don't need some, a lot of community feedback, but please certainly jump into those GitHub issues if these four are of interest to you. We do have a bug fix where we need to fix up how to describe the geo-shaped box format correctly. Secondly, the Google structured data testing tool has been sort of end of life in preference of another tool. And so we just want to go through our documentation and guidelines and update references to that. This third one is really important because as we've sort of published out these guidelines and there's some more advanced topics coming out, we felt like we wanted to present a more simple, streamlined version of the guidelines and then another sort of advanced experience through those guidelines so that all this advanced maybe esoteric publishing practices, aren't a hindrance to folks that are just new and wanting to sort of understand sort of like the simple publishing guidance. And then finally, just some better context in the GitHub README. But right now we want to sort of open it up for discussion and sort of talk through these selected issues. So we encourage you to just unmute and chime in. All right, so this first issue that we're wrestling with is how to specify works cited by a data set. And you find that at issue 42. And this really stems from this schema.org property called citation that is on a data set. And from the schema.org website, it describes that as a citation or reference to another creative work. So that could be like a data set or a publication, web page or scholarly article, things like that. But for the folks that have used like DataCite or Crossref, those vocabularies have, they just don't say, okay, just give me all your citations. They use more descriptive words to describe how things are related. And so that is what we're wrestling with here. So I want to open it up, folks. Please feel free to chime in if you have thoughts on this particular issue. And I can bring up the issue in the browser here if that's helpful. So one of the things that came out of this work is that having these citations is really helpful, but we're wrestling with, do we need, or does schema.org need to describe things like, hey, this is literature, or this is a methods paper, or this is the same data set but a different version of it. So please feel free to chime in.
So I guess if I could just jump in for a second, I mean, if you scroll up a little bit, I think one of the key questions here, right there, that one from Matt, is there's kind of three different scenarios where you might be thinking about this citation, right? One of which is this, where this data set used some other data set, so it's citing it. The second one is, do we want to say, here's how you should cite this data set? So that's the sort of canonical citation. And then there might be other things that are cited by the data set that are related to it, but are not necessarily contributing, as a component of the data set. And right now, the schema.org citation, the way it's defined is pretty ambiguous about what you actually mean when you put something in that citation. And so the issue here is, how do we be a little more clear about what this citation is about? And I think that's a, more of a related resource kind of link.
Yeah, I'd like to see these three cases be differentiated, and I'm not quite sure how to do it with the schema.org citation field, which is, as you said, Adam, pretty generic. I'm curious if anybody has other than these three cases, are there other types of citations that we might want to record within a data set, like other kinds of roles that citing external data or literature might play than these three?
This is Ted. I think that if you look at the relation type code list in DataCite, it has quite a few more than these three, and I think that's a pretty good list of possibilities here that I think goes sort of beyond this guy here. These three that you've got. The question that I would ask, and we had quite a bit of discussion, in the most recent version of the DataCite metadata schema, the piece that we added was a related item, because there were a number of people in the publishing world that wanted a traditional citation for a related item as well as an identifier. And the related identifier has been the only way to identify a related item in DataCite up until version 4.4, which just came out a couple months ago. So my question is, how does this citation element, and I don't know much about schema.org, but how does the citation element relate to sort of the link element? And does the link element have some kind of link? I mean, I think it has link type or something like that. And the question is, when do you need a citation, and when is an identifier enough? And if an identifier is enough, then is a link enough? And does that give you more breadth in terms of describing relationships? I hope that was clear.
Yeah, I think it was, Ted. I think do overlap a lot with the DataCite relation type list. We looked at those pretty carefully. So like the usage citation is, like I said in here, pretty much the cited by property in DataCite's list. The literature cited is like the related item. Different terminology, the same idea. This is something that's not necessarily directly citing it, but it is it's a related linkage, and it could be provided by a link to a DOI or identifier, but it might be a more full-fledged. So like most things in schema.org, you can provide either text or a URL or other representations, and that's kind of what we have to provide conventions and guidelines around, because the world is so open in the schema.org one. But I agree, we should go through that list from DataCite again, just to make sure. Many of those other relation types in the DataCite list are already covered. Like we have many of them, like the provenance relationships, is derived from, is source of, like some of those other types are covered in our provenance guidelines here already. So many of the concepts in that list are divided up into other areas of the guidelines, and we would want to sort of map them around.
One of the ones I think is really important, and I think you've got it, but I just wanted to check. Sorry that I didn't do my homework, is related metadata. Does the schema.org representation that you guys have a mechanism for pointing to more complete metadata?
Yeah, that's recommended with there's a is subject of is what we were using for that.
Yeah, there's a whole section on that in the guidelines.
Yeah. But there is, one possible route using schema.org is it does have a is related to, and currently the expected range for that is, or range includes, is product and service, which is not really what we need. What we'd like is related to creative work. And then they also have in the what do they call it, proposed for full integration section, they have a link and link role. So you can actually put in now a URL. If you use that approach, you can use have a URL that has a role. So that gives you a mechanism. You could use that is related to, and then have it a creative work, and the URL for that implemented as a link with a link role, where the link role would be something like those DataCite relationship types. So it could be engineered. It requires using some of these things that are still in the proposed basket for schema.org, but it does give, sort of a way to engineer a related resource with some kind of semantic association on the link.
Thanks, Steve. That was sort of what I was thinking about.
Yeah, one thing to keep in mind as we're going through these issues is, this is for, the whole point of this is discovery. And so one of the ways that this citation field is getting used, well, by Google anyway, is to link to these related works in Google Scholar for them. But certainly Data One and geocodes and other harvesters might use it, in other ways. And so there might be some advantages to using more than just this citation property and using these other three.
Yep. So for an example for that, for usage citation, right now the DataCite event data service is the sort of like main open database of citation events that exists in the world. It's sort of a Scalex product that DataCite and Crossref work on together. And we use that in Data One to provide our linkages, but we find that most of the citations that exist are not currently registered there. So we have a citation service on the Data One side where people can say that a particular data set, was cited in a paper, and that relationship gets established, and then we report it to DataCite. And so on the schema.org side, if people were reporting usage citations, and then we were finding that those usage citations were not in fact reported to DataCite, we would register them with them so that data source would be more complete, and people could start relying upon it for a broader set of citation information.
I think, I sort of like the link and link role approach, because it puts all the semantics of these links in one place rather than this, what you've got here, usage citation or reference publication or literature cited. It sort of looks like those are element names or items in the schema.org. And the problem is that then if you're trying to make something like a PID graph, you need to know what the names of those links are in the schema.org rather than just going to the sort of consistent link structure and being able to pick up the roles and be confident that you've got all the important links. But I'm not sure that that's, once again, I'm less familiar, obviously, with this stuff than you guys are.
All right. Well, folks, if you have more feedback or if something comes to mind after this session, please feel free to chime in on this issue number 42 on the guidelines. But let's move to the next topic just to make sure we've got time for the others. So let's head back to the slides. And so this next topic is about describing the authoritative copy of a particular data set. Matt, did you want to describe here? I think this is something that's used in the DataCite, or excuse me, the Data One API.
So in this particular case, I opened this issue because we found that Google Dataset Search was listing multiple different sources for a data set, for data sets that we were curating at some of our data repositories at the R2 Data Center. And it was listing other places like DataCite as the authoritative location for that. And so we were trying to understand how Google decides which of, say, 6 different locations where a data set exists, which of those is actually the one maintaining and curating the data. It doesn't appear that there's a lot of pattern in what they're doing. There's 2 separate fields, a publisher field and a provider field. And it seems like providers hold copies and publishers, would be authoritative, but it's not, the pattern isn't that clear. And so the objective of this is to clarify kind of a consistent usage of some of these terms so that harvesters like Google and Data One and geocodes can all consistently try to represent which repository is the authoritative curator for a given data set, presumably list them first, show their logo associated with that particular data set, et cetera. So that's the main goal here. It's been hard to get clarity from Google about just what their algorithm is. We're still reaching out. Doug and I have been talking about reaching out to them again on this. And I think once we get clarity on what Google is doing, if we can, then we really just need to make some minor changes to our guidelines to make sure that people are using publisher and provider in consistent ways. So it's really just clarifying the semantics that are fairly vague in schema.org's definitions. It's related to the preferred identifier issue as well, which is the next one. So presumably the preferred identifier and the authoritative repository probably go together, but.
Right, that's what I've been saying for a while. Yeah, part of the problem is that in many cases, whenever a new place aggregates metadata or copies a data set, they may give it their own identifier, and they may not actually say that the data originally came from some other place. So there's plenty of examples where maybe the metadata will say that this is a Italian data set, but some of the metadata came from England, but the data really came from the Goddard DAC. This is a real example, actually. And so how do you get people to, or how do you figure out where that authoritative source truly is? So that's the point of this one. And I agree, the identifier thing is the next ticket is I think closely linked to this one, and they need to be resolved in concert. And I also note that these two are actually very important to the polder group, which is trying to improve polar data federation. It's a international group with representatives of actually both poles, North and South. and that community's been trying to, over the last many decades, get to the point where they actually have the ability to do a federated search across all repositories globally that have polar data. And so these are two issues that are very important to them to get resolved.
Hey, this is Sky. So first of all, again, thank you so much for all the work that's going into this. This is just a hugely important area. And for myself, who's still sort of dealing with writing, goofy ass code to do things because we're not doing enough schema.org, I'm really excited to see this moving ahead and seeing these problems get dug into. This particular issue though, and the identifier one that's associated with it, seem to some extent like unsolvable problems in practice and at scale. And we're more and more in a place where we're slinging copies of data which are actually transformations of data in one way, shape, or form all over the web. And that stuff is showing up sometimes transient, sometimes more permanent, to serve particular purposes. And it's all useful, especially if it's accessible and especially if it's discoverable, preferably using advertisement methods like schema.org that can be picked up and harvested and pulled into things. The most important thing to me is that everybody pay due diligence to indicating where they got their copy, where they got the last one up the chain, whatever that happens to be. And if that's specified, throughout all of these different forms of data that we have, we can ultimately trace back to, where did these things come from and sort of what's most useful. Obviously, we want to know where something originated and get back to that. And if we can get people to carry that through into all of the different derivations that are out there, that's great. But if that's not always practical, it seems like the most important thing to focus on is indicating exactly where your data came from and who is responsible for it in terms of an identified entity that can be linked to, and what identifier did that entity apply to that, from their end. And getting back to the ultimate authority, I think that's going to be pretty hard, though, in a lot of cases.
Guy, I think you make a fantastic point there. And I want to point out that there is a relationship here to the provenance section. We have got very strong recommendations on how people should indicate that a data set that they hold has been derived from another data set that might exist, using the identifiers to provide the linkages, and if possible, even the process that created that derivation. And so there is a mechanism to say that some data set is some combination of multiple other data sets. And that is, as you alluded to, a really complex set of relationships, and we're not going to model that perfectly, but I think an imperfect indication that data set B was derived from data set A will really help aggregators to help guide people to show that data sets are, like, I think we have a lot of work to do around, like, what does derivation mean, and when is something the same versus something new. We have a lot of synthetic use of data sets where people combine multiple data sets together and they pretty fundamentally transform the data. And other times we have just what I would call sloppy copies. Somebody's moved something over, but they didn't really pay attention. They added a new line at the end of the data file so that the checksum changed, but it really is fundamentally the same data set. I think that we could really try to differentiate when there's a fundamental change in that derivation relationship versus this is meant to be just another copy of the same data set. And it may or may not have a different identifier, and it may or may not meant to be replacing that other one. It's just another place you can find it.
And part of this is, I think, you have the issues of data and data copies and derived data products. But there's also simply the issue of multiple people or groups aggregating metadata and then doing something to the metadata. And so they may have the same underlying data, but because they've updated the metadata, they may think that their metadata is the better metadata, not even though they don't actually even hold the data. So I think it is a little bit of even more complex an issue than has currently been discussed here today, because they're both levels have this kind of an issue.
I agree. And I think there's also issues where repositories could be working together better to make sure that when we, for various reasons, have to copy a data set from another repository, that we make sure those linkages are present, and that if we're supplementing metadata, that we do so. But we really need to make sure that we're not just taking a copy of something that's been issued an identifier and putting another copy out there that's sort of a transformed version of that without sort of indicating those relationships. I think just it's due diligence, I think, is the term Sky used, and I think that really applies here.
Agreed.
I would like, this is Jeff Campbell. I'd like to, first of all, agree entirely with Ruth. Within the federal government, the Geospatial Data Act is really pushing towards geospatial metadata becoming ISO instead of the older FGDC CSDGM. And I have to believe that an awful lot of the legacy metadata will be automatically converted into the newer format. I would hope that this would be a lossless process, but I'm not optimistic to believe that something couldn't get lost in the translation. So now do we have two authoritative metadata records? Is one more authentic than the other one? Yeah, there's a can of worms here.
Yeah, I think that's more of a versioning relationship, and we have ways of specifying that, right? That's something that's part of the provenance trace that we have in the record as well. You can say that a newer version of the metadata replaces an older version, and in replacing it, you might have switched formats, right? So we could have an ISO version of the metadata replace an FGDC version of the metadata, and that's just fine. It's still the same data set, there's two different metadata records, an older and a newer one, and they might have different content and have different schemas.
So it sounds like, I mean, the solution there is in the provenance of the metadata has to be treated the same way as the provenance of the data. And I'm not sure there's a mechanism in schema.org to do that. I'd have to look at our recommendations again.
You know, we treat the model that we wrote up in the schema.org thing kind of treats the provenance thing as a relationship among identifiers. And the things that those identifiers point to can be different types of objects. So sometimes those identifiers will represent the whole data set. Sometimes they'll represent just the metadata record, and sometimes they'll represent individual digital objects within that data set. And you can express provenance relationships, versioning relationships, derivation relationships among all those different types of objects. So I think we could accommodate it with what's currently there. We do that all the time in Data 1 now.
I guess the critical thing there is then recognizing that you need a distinct identifier for the metadata record and for the resource that it describes, right? So you can actually make a statement about the metadata record distinct from the resource that it's about.
Yeah, and we've struggled a little bit with that distinction. Like oftentimes the metadata record and the data set, the resource, as you called it, as a whole, share an identifier. So it is a little hard to sometimes differentiate those. We've talked about we have a package identifier for the overall set, the resource overall, and so it does get a little tricky. It would be nice to have some community discussions around how to differentiate those different concepts and how to label them.
How would somebody who sees that there's now version 3 of the metadata recognize that, well, back in version 1, there's a automated transformation that lost some information? Because normally one would think that version 3 was the latest and greatest. Is there a way of distinguishing?
Yeah, I don't know. I mean, I think ultimately we don't necessarily know what has specifically changed between versions. You can, of course, compare them if you have both copies. And in Data 1, we keep both older and newer copies of everything, so we can always like sort of walk forward on the chain. But like that comparison that Sky made, or Jeff, I guess you made, that was going from FGDC to ISO, that mapping is going to be very complex, right? And it's probably going to be hard to understand. So yeah, I think somebody could look at an individual record, or you could translate it into kind of a harmonized schema like the Data 1 sort of search index, where all the different standards are mapped onto the same common core concept vocabulary, and then you can see which one, what's changed. But yeah, it's pretty complex when you talk about the diversity of standards that are in use.
If you're using 19115-1, we added a field into that's called something other metadata or I can't remember the name of it, or complete metadata or something even like that. And the reason we did that was in this situation that Jeff's talking about, where you're translating from something to something else, or into ISO in this case, we acknowledge the concept that there might be elements that are missing from that translation. And the idea was that this would give you a way to point back to that more complete original metadata. So it was not as certainly not as clean as the kind of provenance stuff that Matt's talking about, but that was sort of the goal there, was to provide coverage of elements that might be in some other, very say taxonomic information, maybe in FGDC or CSTGM that didn't get translated to ISO. So that's something that exists.
I think historians have the same sort of problems, and they try to get back to the original sources for the, they've decided that that's the best way to understand things. So I think if we can try to emphasize, I mean, it's important to be able to get back to the original data. And I think that's going to be valuable for people in the future. So that if we set up systems that can do that, that would be, I think that's really important.
Yeah, so I think these two issues are, the authoritative copy of a data set and the preferred identifier are kind of the handles on which we attach a lot of these more complex versioning and provenance issues. And so it would be, it is, I think, really important for people to be diligent about their assignment of identifiers, about making sure that, the LOD URL plus the actual identifier that's quoted in the schema.org entry is really the primary one people should be using, and not some secondary URL that's pointing to, say, a service that happens to be the place where you can deliver that content today, but rather the actual identifier that will persist for decades for that content. And it's challenging to do well because we have such a dependence on relatively transient domain names and things like that. So yeah, it's an interesting set of challenges, but maybe if we can just clarify how to indicate which copy is authoritative in our metadata, and we point out I'd love for everybody to review the provenance section and give us feedback if there are changes you'd like to see or things aren't clear. That section is one that's already in the 1.2 release, but we could definitely revisit the language if there are things that aren't clear there or that need to be changed. Nothing's written in stone yet, right, Adam?
One other thing that I would just point out about 19115, and this is true of ancient 19115 and also -1, which is also sort of ancient these days. Both of them have scope associated with the provenance section, or the lineage section as it's called there. So it allows you to do a lineage section which has a scope of metadata, and to provide in that section all of the same capabilities that you provide for provenance of the data itself, but have it apply to part of the data set or also to the metadata. So it's maybe something else to keep in mind. And I don't know if you've got that, Matt, in your prov stuff. Would be an interesting, I mean, it was just a dream some of us had that people would actually keep track of provenance either for their data or for their metadata, but some of us are still asleep. We're still dreaming, so.
Yeah, I think the prov stuff that we have in there now is much more like a PID graph, which has an explicit set of relationships and tells you, how you've gotten from one step to another and which, what processing occurred through a set of identifiers. Some of the ISO processing and lineage fields are more narrative in scope, and I think they are a nice complement. Like, I think both of those things are necessary. So we don't really have fields in the science on schema.org that replicate a lot of the narrative descriptions of lineage and processing that are in ISO. This is this perennial debate we have about how detailed we go here. Like, some people argue that the schema.org entry should be a really lightweight advertisement about the existence of a data set and defer to more detailed standards like ISO for diving into those things. Like, we're really focusing on discovery. And so the linkages among objects is really important for discovery. And then the interpretation side, we would defer to, say, an ISO record or something. But we can also imagine a world in which we kind of move to using JSON-LD as a common representation, and we can pull in lots of vocabularies and link them together. So I think there's a bit of tension between simplicity and depth that we keep going back and forth on in these discussions.
That's why sorry, I thought you were done.
No, I'm done.
Oh, that's why the has metadata relation type is so important in DataCite, because DataCite is also thin. It's a thin metadata standard, discovery oriented, like schema.org, but it has this has metadata link. And actually, that is a very rarely utilized element in DataCite metadata. and actually the best example of it is actually ECMWF, which has metadata links for every one of their data site records. And that points to ISO metadata in completely the correct way. So if you're looking for good examples from data site, search for some ECMWF metadata records.
So are there more
Great.
comments on this section, or do you want to move on?
Yeah, going once. Twice. All right. So, I mean, I think the conversation was very similar. So I wonder if we can maybe skip this, but I'm happy to take comments on the preferred identifier if folks want to.
Right. So the main issue here is that we have already the ability to provide multiple identifiers. The identifier field is repeatable. And as a harvester, like when we're like building a citation or we're trying to provide a reference, we just don't know which of those is canonical, because in JSON LD, lists or repeatable elements are not sorted. So there's no way of indicating that, you know, a specific, like if there's 5 DOIs in the list, which one of those DOIs is the preferred one for this data set. So we were thinking about just sorting the list and telling people that make sure your list is sorted and we'll use the first as preferred. But Dave, I think, had some other possible options listed.
Yeah, there are a couple of other options. None of them are terribly satisfying though. I mean, if you look through the issue, then just enumerating them, it's basically, and one option is to use the ID of the identifier property value. That seems like kind of like a bit hacky in that it's kind of an unusual practice to rely on. And there's disambiguating description, same as the list approach that Matt mentioned. And there's, I think, there's several others added below too. It's like Matt added a few down further. Using this another type for the identifier in addition to property value, right? So you can have multiple types for the identifier and so forth. Looks like Steve, you added one down the bottom too, or at least one.
Oh, I think well, there's that one. Well, anyway, there's a lot of options.
Yeah. So the upshot is that none of them seem terribly satisfying, really. They're all kind of conventions unless we use a a specific term or property added to a particular identifier in the list. My preference, just because it's kind of easy to do, is to use like a sorted list and use the first identifier as the preferred. But that's just a convention. It's not really something that's explicit.
Yeah, Dave, that seems a little bit logical to me. If a repository has gone through the work of using the at list or specifying that this is a sorted list, then yeah, it seems okay to me to assume that that first one is the preferred.
So if a harvester were to, I think that's great too. I just don't know what we would do as a harvester if we encounter a data set that isn't using the sorted list. Then what do we do? Do we treat it as if it were sorted and we just take the first one that happens to be in the JSON LD document, which might be in arbitrary order? Or or do we just accept the fact that because the repository didn't provide, at list in a sorted list, that they don't care which one is a preferred. I guess
this
that data set for multiple repositories, and they each say that a different identifier is the preferred one. I'm not sure which.
Might they each say that theirs is the preserved one or the preferred one?
Typically, yeah.
I think in practical usage, harvesters, we're going to almost always have to dereference and content negotiate those DOIs and figure out what they actually mean on the other end of that information anyway, and then decide based on what we're trying to do, what do we do with that information? What do we do with what's provided? And I mean, I think that, you know, we pretty quickly run into a problem of, you know, definition anyway. What does preferred mean in terms of the DOI that I list first? So, you know, I think that the basic convention here of saying, you know, look, put a sorted list in and it means something. And maybe as a repository, you have something somewhere that tells people what you mean by putting things in a particular list order. And that might be helpful down the line. But I think in practical terms, you know, when there actually are potentially more than one DOI associated with a data set that somebody is advertising via schema.org, it's great that they're actually all provided. Put them out there, and then, you know, let us dig through it and figure out what to do with what's been provided there. I agree with Dave. It's not satisfying. It'd be nice if we could sort of nail these things down. But the reality of how things work is that we're going to end up with that situation all the time.
I think the thing that's unsatisfying about the sorted list is simply that it's the importance of it is so implicit. Like, it's not an explicit indication of which one is the preferred one. So, yeah. Well, I think that we're probably heading towards a sorted list solution. So if folks have different ideas or want to highlight other things, I encourage you to put entries in the ticket or join our calls and we can further discuss it. It seems
Look
like
at all the different options and see what you think.
Yeah.
All right, so you know, the next issue that we're wrestling with is, you know, how to specify the keywords from vocabulary. Schema.org gives us a way to talk about a defined term, and so you can say that, you know, nutrients is a keyword, and, you know, it's defined in this vocabulary using this at this URL. You know, that's certainly good, but, you know, I guess one of the things we're wrestling with is, do we need to specify what vocabulary and the name of that vocabulary? And so just curious about if folks find this useful, or just being able to provide the string value is good enough for discovery. What do folks think?
Well, one of the advantages of scoping the keywords is the kind of pattern that's used in the ISO metadata, where you can have location keywords and theme keywords. And so it gives you a way to sort of understand a little bit better what the keyword might be about. And defined term gives you a way to do that, but that, yeah, then you need some conventions about, well, how do you identify the vocabularies we're using?
Well, I think having a convention for identifying the vocabulary you're using isn't a very important thing to do, because I tend to fall on the use schema.org where that's useful, and then branch off to more complete things when you need to, and in particular, ideally ontologies where they exist.
Yep. Yeah, I kind of think that using, I mean, clearly there's a lot of undefined terms that will be present, and we just need a plain keyword, you know, list, and that's fine. But people will also want to label their data sets with more defined terms that are tied to specific concepts from ontologies and other vocabularies. So personally, I think the property ID approach gives us better ability to link out to other ontologies than defined term does. But yeah, we seem to fall back to that a lot.
Yeah, so I can put on the screen an example of defined terms so you get a sense of what Matt's talking about here. So this is it.
So the term set is the vocabulary, and then they have a term code, which would be some kind of, in this case, an abbreviation, but it also allows, since it's a schema thing, you can have a name and a description and all those other things with each term as well.
Right. So if we interpreted in defined term set always as a URI and basically use that as the namespace of the vocabulary and the term code as the concept identifier for that concept, and that those appended together make our term URI, then this is probably equivalent to property ID, right? But those ifs are big ifs.
Big ifs. So Matt, are you suggesting using additional property with a property ID, or using property value as the type for keyword?
Yeah, I think I was thinking about property value as type for keyword, but I don't have a super strong opinion about that. I think defined term is a better semantic fit if we could just really be rigorous about linking out to those external vocabularies.
And then just to put on the screen, just demonstrating if that particular term has a URI or URL, you could specify that using the add ID.
And then there's no way here to do the keyword typing that Steve was talking about, except by inferring it from the URL or the URI of the vocabulary.
Right.
Yeah, I think the vocabulary, like if terms have superclasses that are types or categorized, and that would be part of the vocabulary definition more than the in the metadata document, right?
Right. So you can't say here's a set of keywords that are related to this particular term set, the way this is set up.
Yeah, Andrea in the chat just asked the question, what about version and revision date of the keyword list? Thoughts on that question?
Well, Andrea, can you clarify what it is you're the version part in particular? Like, are you thinking through multiple metadata records? Like, or what do you mean?
So in the chat, Andrea says in ISO. Oh, there we go. Hey, Andrea.
Can you hear me?
Yes.
I just take my headphone. Just a minute. I'm surprised. Sure, in English, so pardon me. But in the ISO standard 19115, there's a citation entity, and you do the whole complex to the whole attributes of the citation. It's the title, everything about, not everything, but very much about the thesaurus. I note, I type the thesaurus, I think. But I'm not ready for show it as an example here. Excuse me.
That's okay. Thanks for chiming in.
This is something that started, at least in my experience, in CSDGM, sort of the authority for a keyword. And it seems to me that in practice, the URL to the keyword, or even in a lot of cases, a prefix on it, is sort of maybe superseding that sort of concept of authority for a keyword and using a full citation there is just, it seems to be fairly rare.
Yes, but the list can change. The URL might be the same, but the words in it can be on another date on another content.
Yeah.
So this is the problem. I don't know if it's a big problem.
I agree with you that this is a problem, and I think a good example is some of the if a vocabulary is revised and subdivides something that already existed, you may not be able to tell exactly what it was that they were referring to. GCMD has had some examples that we've encountered, which caused a lot of validation issues, checking terms against the supposed thesaurus when the versions were different.
Yep. Yeah, so I think best practice would be to use term URIs that are very explicit about the term instead of pointing at a thesaurus and its, say, natural language keywords. The term URIs can be harder for humans to interpret, right? But
sorry, by thesaurus, I was using the ISO sense of thesaurus as being the identifier of the controlled vocabulary.
right, and yeah, and so was I.
Oh, okay. Yeah. Okay. Yeah. Yeah. I'm sorry. I misunderstood for a second.
That's talking about identifier for the key, for the actual keyword, or in addition to an identifier for the, as something which is different than an identifier for the vocabulary.
So in the example we're looking at there, the @ID would be the identifier for the keyword, name would be the label for the keyword that you would show in the UI, and the defined term set would be the URI for the vocabulary. Is that kind of the direction we're going?
So yeah, the challenge is that the @ID, I mean, it has to be a URI because it's a linked data URI. So some vocabularies might be a little challenged with that, like GCMD.
Right. Yes, a non-trivial example.
All right, well, we've got 8 minutes left and I want to give some time to this last issue. But thank you all for participating. You're really getting a slice of what it's like to be on a schema.org call. And so if you dig these types of conversations, we invite you to our calls, and I'll have a slide at the end here that shows the information to keep in touch with us. Okay, so the last issue, I don't know if Nick Jarbo is still on the call here. Nick, did you want to just sort of describe the issue and kind of where we're at?
Yeah, so the ISO time only works for sort of modern era. And so many people have geological timescales they want to discuss. And we want to try to incorporate that. And there's sort of two main issues, or two main descriptions of time. One is using geologic terms that were sort of in the sedimentary record, like Phanerozoic or Mesozoic or Cretaceous and so on. And the boundaries between these timescales change as better dating methods occur and improvements happen. And then there's another time scale is where you do absolute dating with radiometric dating, where you do radioactive decay and you take measurements, and then you have a defined date with uncertainties. And we'd like to be able to describe both of these, but there's not very good online standards for referencing these issues. So we sort of set up our own site to define some very minimalist timescales, like millions of years ago and BC, before present and other terms, but getting to where we can do more complicated timescale work, we haven't quite decided which sources we should use. And for radiometric dating, we'd like to have something a little more sophisticated that can deal with uncertainty and various other things that we're not ready to put online ourselves.
I'd like to add, I sort of drafted up a proposed update to try to address some of these issues. That's in the there's a link to it somewhere down there at the bottom, I think. But the basic idea that okay, we need to represent intervals and instance. This is sort of following the OWL time thinking, and use the OWL time has time property for this more generic kind of representation of time. And for interoperability, the proposal would be give a numeric age position in millions of years, 1950 before present standard sort of geologic time, numeric time scale. And then if you have a named time ordinal era, and those might be from the standard geologic time scale, but we also have magnetostratigraphic crons, we have astronomical cycle crons, we have all kinds of different paleontological time scale things, like the Ontoceras Woodwardi zone or something like that. So there's a lot of different ways that there are named intervals in time that people might want to use. But for interoperability, the idea would be to say, okay, give us the closest subsuming age that you can give us from the International Chronostratigraphic chart, which is the standard geologic time scale from the International Commission on Stratigraphy or whatever it is. And then there's a text value that you can use in schema temporal coverage, and that could provide a user-friendly statement that would use whatever was familiar for the people looking, but would not be necessarily useful for data aggregators trying to integrate these various descriptions of time intervals in an aggregator and a search interface. So it's a pretty dumbed down solution, but it gives you some interoperability and provides some degree of solution for the problem.
All right.
I think having a dumbed down solution that we can put into 1.3 is a good idea, because people will be doing their own systems to describe deep time if we don't have it, I think.
Yeah, Steve, I really like the solution you propose here, being completely not well versed in deep time. This seems like really tractable. All right, folks. Well, thank you so much for participating here. We really appreciate it. As part of the cluster, we meet on the first Monday at 5 p.m. Eastern, the fourth Thursday at 2:30 p.m. Eastern. We'll be tackling these issues and a couple more as we wrap up version 1.3. We encourage you to engage us at those telecons or at the GitHub issue. Thank you for participating here. And we'll be updating this email list and Slack on our progress as we get towards the endorsement. And certainly we'll announce that endorsement package when it's ready, so that folks can review that and comment on it, so that we can walk everyone through the Esip endorsed Science on Schema.org guidelines at the winter meeting in 2022. So thank you for attending. Really appreciate you being here and spending time with us today. Enjoy the rest of the Esip summer meeting. Thank you.
Great.
Thanks,
All right.
Adam.
Thanks, everyone. Thank you, Adam, for
Thank you.
wrangling the cats here.